Hi, we are engineering brothers, and once again we have got our another S-plane plot over here. And quite naturally, we do require to give you the best form of analogy regarding our stability over here. So let us start our considered analysis over here. In our S-plane, or according to our S-plane, we do know that the exact transfer function seems to be this one, which is this is the ratio for a transfer function, which is output divided by input, which is Cs divided by Rs. And according to our analogy over here, the pole is being considered in our denominator part over here. That is why we have written that 1 divided by this one. And according to our pole position over here, we do know that the complex conjugate analysis will be there, which is 1s plus J1 and S minus J1 over here. Why do I consider that? Because these two pole location will be this one, and this one will be our for this one. Why? Because what is the considered part? If you just do put that denominator portion, that will be equal to 0, and this will be our analysis over here. Quite naturally, we do have the considered part, which we can say that the first one will be considered as our S1, which is minus J1, and this one will be S2, that will be our plus J1. And which one is our plus J1? This one. Now we have considered plus J1 over here, and this one will be minus J1 over here. Quite naturally, we are having this equation over here. And how do I get to that considered point? I have shown you over there. No other YouTube channel or no other textbook will like to give you this type of detailed analysis over here. So I always do encourage you to subscribe our channel, hit the bell icon for more updates, and stay tuned with our classes. Once again, according to our S-plane, we have considered this will be our given equation for our system over here, and this one will be our GS over here. And we do require to find out whether the system is stable or not. Before I go into that, we have plotted our considered S-plane over here. According to our S-plane, we have put that in our given equation over here. And how do I consider these two poles over here that I have shown you over here? Quite naturally, this one will be our S plus G1, which actually indicate this one. Now this point over here. Similarly, for this expression, this one is this one. And how do we get the points of our pole in our S-plane? We have shown you over here. The denominator portion will be 0 over here. So these two will be considered as a 0 portion over here. And according to that considered part, we are having our plotting points over here. This one is our plus G1. This one will be our minus G1. Now this one will be indicated as this one. Now quite naturally, we do require to solve this given expression or equation over here. And how do you solve that over here? I do require the complex analysis over here, and this one will be our A plus B, formulation of A plus B and A minus B over here. And according to our considered formulation, the exact formula will be A square minus B square over here. According to our given equation for our GS, the S plus G1 and quite naturally S minus G1 will be given as S square minus our G1 square over here. Now quite naturally, this one will be S square minus G square 1 square. And according to our analogy, we do know that the value of G will be square root of minus 1 over here, and if you just square on both sides in our given equation, we are having J square is equal to minus 1 over here. Now this one will be S square minus actually to give us plus, this one will 1 square. Now quite naturally, this one will be S square plus 1 square over here. Now we can write that as our 1 divided by A square plus 1 squared over here. Okay, which actually do give us the considered analogy over here. And I have already shown you this portion over here. Now I want to replace this portion once again because this portion is very vital. According to the S-plane over here, we have plotted or we have considered our transfer function over here, which one will be this one. And how do we get to that point? Because of this plus of J1 point, we have considered as our this one, and for our minus J1 point, we have considered this one. And how do we plot that? We have already shown you over here. And how to solve or getting solved these given equations over here. The formula will be a plus b, a minus b, which actually do give us a square minus b square. And according to our present analysis for our transfer function, we have put that accordingly. And after that, we are having a square plus of 1 squared over here. Now quite naturally we have put that over here. Now the next step will be to apply the inverse Laplace transform in this given expression to have the considered analogy over here. But before we go into that, once again we do require to apply the impulse response over here, which is Rs is equal to 1. For this type of analogy, for our effect of our poles on the stability, we do require to put the impulse response over there. That will be constant for all those systems over there. Now ultimately Cs, this one will be 1, that actually give us 1 divided by s squared plus 1 squared over here. Now ultimately we are having Cs is equal to 1 divided by s squared plus 1 squared over here. Now in order to get the considered output analysis over here, we do require to apply once again the inverse Laplace over here. After we do apply inverse Laplace on this given S domain equation, we are having Ct is equal to quite naturally our sin t over here, and quite naturally this will be our time domain analysis over here. And we have considered that Ct is equal to sin t over here, and that is the plot over here. According to our analogy, we do know that the sine plot do start from 0 and it is being flowing in this way. And quite naturally, as according to our S-plane analogy, we do know that if the poles are placed in the left hand side of our analogy or left hand side of our S-plane, we can say that the system is stable. And if the poles are present at the right hand side of our S-plane, then that will be unstable. But in this case, that is not been placed at the right hand side and that is not been placed in the left hand side as well. These poles or that two poles are placed in between the stable and unstable region over here. It is being placed at the axis of our imaginary axis over here. It is being placed at the axis. Because of that, if you just do shift these poles at the right hand side of our analogy, these will become unstable. If you just do shift these poles to the left hand side of our analogy or left hand side of our S-plane, this will become stable. But if the condition is then that is been placed at the middle part of our S-plane, then we can say that the system is marginally stable. And there is another analogy over here how to explain that. If you just do like to increase that, if we say t tends to infinity, then these curve do have the oscillatory nature over there, and it is not increasing or not decreasing in that way, but that is keep on moving in that way. If you just do like to continue with that analogy over here, that is not increasing and not decreasing over here. Because of that, we can say that this system is marginally stable. This one will be marginally stable. That is not in the unstable region and that is not in the stable region, but that is being present at the axis, which is actually do give us the marginally stable consideration over here, and according to that S plan we can analysis that, and according to our time domain analysis over here, which we have considered or we are getting after we have applied the inverse Laplace over here. And how do we get to that point? Because it is according to our analogy, according to our analysis, we do realize that this waveform is not increasing or not decreasing in that way. It is keep on the considered oscillatory nature over there, and it is been giving us that oscillatory nature over there, but that oscillatory waveform is not decaying or not been increasing over here, and because of that considered point we can say that this system do have the analogy of our marginally stable considered point over here. In our next class we do require to analyze this S plane, and according to that how do we comment on that time domain analysis over there for according to our output over here. I hope you have totally understood up to this one. If you still have any doubts, please let us know in the comment section for better understanding. Do like, do share our videos, and keep following our channel. That's it. Thank you and goodbye. If you like my video, so what are you waiting for? Please do subscribe my channel, hit the bell icon for more updates, and stay tuned to the channel. Thank you and goodbye.